Hey, what's going on, guys? In this video we are going to see how to apply open circuit method for a diode circuit. Here we have a diode circuit, and the open circuit method is basically we remove this diode from the circuit, we replace that one with open, and we calculate this VA voltage and VK voltage. Let's look at what is this VA voltage and VK voltage. For a diode, the back side, like you can see, this side is anode side, so that's why this is VA, and this line side is cathode side, that's why this is VK. Okay, now there are two different cases. We can have ideal diode and also we can have practical diode. If it's an ideal diode, if the VA value is greater than VK value, then we replace that one with a short circuit. Okay, and also we can say this is forward bias. It means the diode is on. Okay, and if it's otherwise, if the VA value is less than VK, we replace that one with open. Otherwise it's open. Okay, for a practical diode, this is different than ideal. This VA minus VK value, if it's greater than 0.7, this is forward bias and on. We replace that one with a 0.7 voltage drop. Okay, 0.7 voltage drop, and this is forward bias. So this one is forward bias, it means the diode is on, and this is like when it's open, this is reverse bias. And also if otherwise, if the VA minus VK value is less than 0.7, it's open. VA minus VK value is less than 0.7, this we replace that one with open circuit. Now let's look at this problem. Assume that the diode is in the figure has V on 0.7 voltage, but is otherwise ideal. Find the magnitude of the current I2. Okay, so here we are going to apply open circuit method, and here we know this is a practical diode. Okay, so we have to look at VA minus VK value, and first we replace that one with open circuit. So the equal circuit is going to be look like this. So for this one, the equivalent like open circuit is going to look like this: plus minus, and we remove the diode. This is going to be VA and this is VK. Now let's try this problem. For this one, we remove this diode, and the open circuit is going to look like this. This is VA, this is VK, and here we have a voltage source, 2 voltage, and here we have a resistance R2 that is equal to 6 kilo ohm, and here we have let's call this R1, 2 kilo ohm, and I2 is flowing through this one, and that's it. Now the question here is asking us to find out this I2 current. This is 2 voltage, and this is anode side, right? Because this is back side, like you can see this is the anode side of the diode, so that's why this is VA. This is cathode side of the diode, so that's why this is VK. Now here we have VA, this is VK. VA is easy to find, and this one is connected with ground. Okay, this one is connected with ground, so this is 0 voltage. So here you can see this is 0 voltage, this is 2 voltage, so VA is going to be 2 minus 0, that's going to be 2 voltage. So VA is equal to 2 voltage. VK we don't know, right? We don't know what's the voltage is. If we find out the voltage across this resistor, that's gonna be the voltage for VK. Now to find that one, we can apply KVL. Let's use a different color. KVL. Let's say current is flowing in this direction. So plus minus. So it means current is flowing through minus to plus. So it means negative 2 voltage. Plus I times 2 plus 6. 2 plus 6 kilo ohm. That is equal to 0. That's KVL. Now if we rearrange this one, this is going to give us I is equal to 2 divided by 8K, and that's going to give us 104 milliampere. It means 0.25 milliampere, or we can say 104 milliampere. Okay, so this is our current. Now our purpose is to find out the voltage here, because we are going to see what's going to be the VA minus VK. We have to see whether this is open, like this is in forward bias or reverse bias. So this is 1 over 4 milliampere. If we find the voltage across the resistance, that's going to be the Vk. So we multiply this current, because V is equal to IR, current times the resistance, that's going to give us 3 over 2, 1.5. This is milliampere, so milli kilo cancels, so 1.5 voltage. V is 2 voltage, and Vk is 1.5. Va minus Vk, 2 minus 1.5, that is equal to 0.5, right? 0.5. And here you can see, for a practical diode, Va minus Vk should be greater than 0.7. Here we are having less than 0. This is less than 0.7, right? 0.5 is less than 0.7. So it means we replace this one with open circuit. We already assume this is open, so we don't have to do anything. Our purpose is to find out the I2 current. Since this is open and this is a correct diagram, our I current is going to be the I2 current, because we found out what the current is, and the current is going to be same everywhere because all of them are in series. So I is going to be the I2 current, so we can say I2 is equal to 0.25 milliampere. And that's how we do this kind of problems. I hope this helps. Thanks for watching.